Hi team, now we're going to look at special triangles and radians. And the special triangles that I'm referring to are 90-degree or right triangles. And the measurement of the other angles are either 30 degrees and 60 degrees or 45 and 45 degree triangles. Let's focus on the 30, 60, 90 triangles first. Okay, that's these guys here, and I apologize for that yellow arrow cursor that got copied and pasted. Okay, so notice in this left triangle, my 30 degrees that I'm focusing on there, the side across from the 30 degrees is 1/2, and then the side next to or adjacent to that 30 degrees has a measurement of rad 3, or the square root of 3 over 2, when the hypotenuse is 1. And remember, the hypotenuse is always the side across from that 90-degree angle. If we take a look at that same triangle, but focus on the 60 degrees over here on that purple triangle to the right, notice that the sides still have those same ratios. It's just the longer side, because square root of 3 over 2 is a larger number than 1 over 2, is across from the 60-degree angle. And the 1/2 is still across from the 30-degree angle. That is always the case. So one of the things we may want to state up here is that it does not matter how we arrange the 30, 60, 90 triangle. The larger side, I think, is across from the larger angle, and the smaller side is across from the smaller angle. Okay, and that is true for all triangles. Okay, that's always the case. The larger side is across from the larger angle. So if we go back down to this first triangle here on the left, if this is our 60-degree angle and our 30-degree angle, notice the larger side is across from that larger angle. The smaller side is across from the smaller angle. And again, 90 is the largest of those three angles, and 1 is larger than the square root of 3 over 2, or 1/2. If we look down here at the 45, 45, 90 triangle, so we have the 90 degrees in the bottom right corner. If that left side is 45 degrees, that means this other side is also 45 degrees. So even though the picture there may not be to scale, this is what we call an isosceles triangle. So if those two angles are the same, then that means the two sides are going to be the same length. And both of them will always have that ratio of square root of 2 over 2 when your radius is 1. The reason I am bringing up these special triangles early is because being familiar with these triangles are really going to help you with your trig, okay, which is going to be coming up pretty soon. So I'm kind of warming you guys up. So let's look at this top left triangle again. If we were to consider putting this on an XY axis, so there's Y, and if this is the X, then we can consider that bottom length of that triangle to be the width of our X value. And then this upright side of the triangle, the 1/2, to be the width of the Y value. So we can actually do that for every triangle in existence, is to place them on an XY coordinate system. There's our y, and this is our x. And we're actually going to be doing that again later. This is what we call the standard position of an angle when we're putting it on a coordinate grid. And so we want to memorize all of these ratios, these sides of these triangles, like coordinate points. So for example, if we're looking at 30 degrees, the 30-degree triangle up in the top left in blue has an x value of rad3/2. So notice it has a larger x value and a smaller y value of 1/2. Whereas if we're focusing on the 60-degree, the ratios are the same, they're just in a different place. With a 60-degree, your x value is smaller, it's the 1/2, and the y value is the larger rad3/2. We love 45, 45, 90-degree triangles. That 45-degree, because they're both the same. Rad2/2, rad2/2. So here's what I want you guys to do is to memorize, let's box these in. I want you guys to memorize right now just those 3 coordinate points, okay? 30 degrees gives us a rad3/2 and a 1/2. 60 degrees, the 1/2, rad3/2, they're switched. And then the 45 degrees, rad2/2 for both. If you memorize those now, trust me, your life, once we get to chapter 5, is going to be so much easier. All right. Now, there's another concept that I want us to cover, and that is radians. Now, a radian is another measurement for an angle, and it has no units. That's all I'm going to tell you about it for right now. We will learn in more detail how it's measured in chapter 5. But for right now, I just want you to know that 180 degrees, and remember, 180 degrees, like if this is 0 degrees, all the way to here is 180 degrees. Some people call it the straight angle. It goes all the way across. 90 degrees is the midway point. Okay. So 180 degrees is equal to pi radians. You always wondered where that number pi is going to come in into play. Here we go, especially in radians. So the fact that those two are equivalent, 180 degrees and pi radians, we can write them in a fraction form, either 180 degrees over pi or pi over 180 degrees. It doesn't matter. They are both equal to 1. So that means we can multiply any number by pi over 180 degrees or 180 degrees over pi and not change the value of that angle. In other words, we can convert from degrees to radians or from radians to degrees. So here's your hint. Use the one fraction, that one ratio, where the final measurement that you want is on top. In other words, if we were converting 2 degrees, then we're going to keep the one with the 180 degrees on top. If we are converting to radians, then we want the pi radians on top. So let's do some conversions. If we're converting these degrees to radian, so if we're converting 30 degrees, we're going to multiply by the fraction that has 180 degrees in the denominator so that the units of degrees would reduce, they would divide out, and I'm going to leave my pi on top. Well, 30 goes into 186 times. So 30 degrees is equivalent to pi over 6 radians. If we do B, 45 degrees, again, converting it to radians, we're going to leave the radians on top because we want our degrees to divide out. So we put the 180 degrees on bottom. So 45 goes into 180 4 times. So that gives us pi over 4 radians. 60 degrees, same thing, multiplied by pi over 180 degrees. 60 goes into 180 3 times, so that leaves us with pi over 3 radians. Last but not least, 90 degrees multiplied by pi over 180 degrees. And that will give us pi over 2 radians. So notice all of the degrees would divide out because those are on top and the 180s are on the bottom. So now when we convert radians to degrees, we still multiply by the fraction, but this time we're wanting to keep the degrees and reduce the radians. So when we multiply here, 12 goes into 180 15 times. The pi's reduce, so that gives us a negative 165 degrees. In B, we do the same thing, converting radians to degrees, multiplied by 180 degrees over pi radians. 3 goes into 180 60 times. 2 times 60 is 120. So this gives us 120 degrees. 7 pi over 6, multiply it by 180 degrees over pi. Pi's reduce, 6 goes into 180 30 times, so that gives us 210 degrees. So notice on D, we don't see a pi, but that's okay. They're telling us up here that we have radians. So instead of doing it in terms of pi, which remember is an irrational number, 3.14, and that decimal goes on forever, they're just giving it to us in decimal form. So 2.4 times 180 degrees over pi. And if we put that in our calculator, we get approximately 137.5 degrees. So here is a tip from your Aunt Lainey. If you're working in degrees, always write the degree symbol. If you do not see the degree symbol, then we generally assume we are in radians, unless there's been a typo. Also, if the original problem gives you any information in radians, you are to give your answer in radians. If the original problem gives you information in degrees, you are to give your answer in degrees. They don't mix the two within the same problem. So that's it for our preview on special triangles and radians. So please remember those conversions, the 180 degrees over pi and pi over 180 degrees. And also memorize those coordinate points, those ratios for the 30 degrees, 60 degrees, and 45-degree angles. Thanks, guys. Remember, if you have any questions, come and see me during my office hours or shoot me an email through the inbox in Canvas. See you soon.